Guys, please, any doubts you have from week 11? Okay, so let me start showing. First question, all of you solved this first question, practice assignment questions of week 11?
Ma'am, discussion is done, ma'am. Practice assignment is done.
Okay. So, do you have any other doubts then?
Ma'am, could you discuss week 10's pseudocodes, ma'am? Could you explain them? Week 10 summary session wasn't conducted.
Yes, week 10 pseudocode.
Yeah, I will explain whatever that is there in the slides, okay? So just I will explain whatever that is there in the slides, or do you have any specific doubt?
No, ma'am, you can explain the slides.
Yes, ma'am. Please explain the slides. Discuss the whole pseudocode.
Yeah, sure. So trains data set has information about the trains and stations, right? Train data set will have the trains card and stations card. And trains card, see that has the information of all the trains and station. Each train is a route list of station. Each train is a route of list of stations. So for this train, 12259 goes through all these stations. Like it starts from Kolkata and it stops at Bikaner. Each station is a route list of trains passing through. So each station will have the routes of list of trains passing through that station. So Nagpur station, to the Nagpur station, all these trains passes by. Okay. So if you wanted to compute pairs of stations connected by a direct route, if you wanted to compute the pairs of stations that are connected by a direct train, represent the start and end of the station of trains in a nested dictionary. Represent start and end of the state of the trains in a nested dictionary. Okay, in a nested dictionary, we are writing the train start and train end. So actually, we have to compute the pairs of stations connected by a direct train. Okay. Just give me a minute. Okay. I think there is some noise. Is there some noise from my side? Background noise?
No, ma'am, it's okay.
Okay. Compute pairs of stations connected by a direct train. We have to compute the pairs of stations that are connected by a direct train. So the starting station and the ending station of the train are connected by a direct train only, right? So Kolkata and Bikaner, these stations are connected by this train 12259. Okay. They are present start and end station of the trains in a next dictionary. So we can in the next dictionary, we can do that. Okay, I will explain this in the code. Stations A and B are such that the train starts with at A and ends at B. So stations A and B such that the trains start at A and ends at B. So procedure direct routes is a procedure that computes the pairs of stations which are connected by a direct train. Okay, direct route is a procedure that computes the pairs of stations which are connected by a direct train. It takes the trains as the input. Stations A and B such that the train starts at A and ends at B. Okay, the same thing. So stations is the thing that stores that. For each T in keys of trains. So what are the keys of trains?
Train numbers.
Stations, ma'am.
Train number.
Keys of train is the train numbers. And what is the dictionary corresponding to the train? What is our
Ma'am,
train? Wait.
train number with a dictionary, starting station
And yeah.
and ending station. Ma'am, what is the value? Means for inner key, starting station, what is the value for starting station?
Only true.
Yeah, just I will write this there. Yeah, I think I have to download the slides to write. Just I should download to write it. Okay. So now we have trains. Trains is a dictionary that has train numbers like 12257 something that is mapped to the list of stations the train passes by, right? So let us say the same example here 12259 12259 and the starting station is Kolkata and it is mapped to true. And I will write all the stations. It will have all the station names through which the train passes by. So next station and everything, right? And the ending station, Bikaner. That is also mapped to true. List of all the stations through which the train passes by, right?
Ma'am, it will have only the starting and ending station, no?
It will have only the starting and ending station. Okay. Here the dictionary, it has start and end, no?
Yes, ma'am.
Okay.
In Twins Dictionary.
Yeah, it is a dictionary and it has a starting and ending.
No, ma'am. Trains data set will contain all the stations.
Yeah, trains will have all the things.
Stations dictionary will contain only start and end, which will be mapped to true, I guess.
Yes.
I think we have to go to the lectures for this thing. So
Uh,
trains of T of start, the trains of T is some number. So start and end is a key, definitely. Because we are saying trains of T, we know T is some train number only. T is the
yes,
key,
ma'am.
which is a train number, and start and end are also true. That means start is a key.
Starting station, ma'am. In lecture, I have seen start is starting station and end is ending station.
Uh, Start is a key, that means and end is a, but it should be a station name, no?
Yeah, station name only, ma'am. Starting station name and ending station name.
Okay, that is Kolkata and Bikaner. Let us see in this way. Okay. Bikaner. Okay. What we are doing here? We are computing the pairs of stations that are connected by a direct train. So if it is a starting and ending station of a train, then it is connected by a direct train, right? So what we are doing here, stations is an empty dictionary initially. So that direct routes computes the pairs of stations which are connected by a direct train. So for this particular train, for any train, the starting station and the ending station are definitely connected by a direct train. No? So that's why. So stations of trains. Okay, here we are accessing the value of start. So start is a key. Start is a key and the corresponding value is the station name. In the trains dictionary, this is how our trains dictionary will have. It has start as key, and it is mapped to the starting station. End as key, and it is mapped to ending station.
Here we are mapping the value true to start and end. So
Yeah, in the
it will-
stations.
yeah,
Now
it will-
stations is a dictionary. In the stations dictionary, you can see stations is an empty dictionary. What we are doing here, for each train, for each T in keys of train, that means for each train number, stations of trains of T of start. That means the starting station and ending station. We are getting the starting station and the ending station. That we are marking as true. You can see. So for stations,
keys train will be contain all the data inside that train's dictionary. All the stations will be there for that particular station or train. In keys train, what it will be storing then?
in case of trains, it will be the train numbers. Right? Keys of trains is nothing but the train number. Trains is a dictionary with the keys mapped to another dictionary. So keys of trains is nothing but a train numbers of all the trains. Okay.
Okay. And in the first stations, trains T start equal to true means?
True. So trains of T of start. So trains dictionary is already there. So in
Yeah.
the trains dictionary is such that it has the key as the train number and it is mapped to another dictionary where it has the starting and the ending station as the keys. Start and end as the keys. The start is mapped to the starting station and end is mapped to the ending station name. Okay. So in the stations, what we are doing? We are doing station.
Ma'am, over here a small confusion. What under what keys the other stations are like stored, like Dhanbad, Varanasi, and all, which are there? How are they stored, or only start and end is stored?
Only start and end is stored.
Okay.
Hello. Ma'am,
Yeah.
you assigned a coding teacher for me, not for maths. I wanted for maths.
You
Hello.
wanted yes, Malavika. What
Yeah,
you want?
ma'am, yeah. You assigned a coding teacher for me, ma'am. I wanted maths teacher.
You want math session, huh?
Oh.
Now this is CT session, no, Malavika?
No, that is the website where they told us what is there.
I guess it's
Yeah.
from 8 to 10, I guess, no?
Okay, CT session is from 6 to 8, Malavika.
Same one?
Saturday CT session is 6 to 8. Anyone, any others? Math session.
Okay, can you just tell them the name of the thing? Because it's very basic and I think they'll know it. It's maths, ma'am. It's maths. It's basics of whatever we've learned 11th and 12th.
Ma'am, I think she's talking with someone else.
Content matlab the video. I have only recorded videos. The name of the thing.
Excuse me, ma'am, I have a small doubt. Ma'am, in these trains where we are actually setting up this trains dictionary. So how do we get to know that in the starting, like the start that we have a key, start we need to store the first station that is coming, and at the end we have to like this key named end, we have to start the ending station. Like we have to store this ending station.
Yeah,
So I
that's
think
how
this should be a
that's how the trains dictionary is framed. Yeah, actually, I could have explained that the trains dictionary, but it is not there here. In week 9, is the train dictionary there? Or, yeah, in any week?
no, ma'am. Ma'am, actually, I know about that. Like what I want to say is when we're writing the code where we are assigning the value to the start and end, I think we should write that this start will store the value which is the first of that list, trains list, the
Yes,
first value, and
yes,
end will be the last.
yes.
But ma'am, in the code, I think it is not given. They're directly saying that it will store the starting station and ending station. But I think we should specify that in the code.
Yeah, trains dictionary we are not forming here. We are trains dictionary is already there for us. What we are doing, we are just computing the pairs of stations that are connected by direct train. So we want now stations dictionary. Station dictionary is already computed. That is already there for us.
Okay, so we're assuming that it's already there and therefore we are not writing the code for it. Okay.
Yeah, we are not ready. It's already done actually. It's already done. In week 10 only might be to have done. Okay, but in the lectures, it's not there. In lecture slides, it is not there. Yeah, what I'm doing is now I'm explaining the lecture slides of whatever that is there in your, whatever that are available in your supplementary contents. Okay.
So here what we have to assume is the start train and end train is there in that dictionary which we are mapping to true, right?
Yes. So this is how now we are just assuming the trains dictionary is in this structure. That's all. Trains dictionary has some train number that is mapped to another dictionary. In that another dictionary, it has start and end as keys. The start is mapped to the starting station name and end is mapped to the ending station name. Okay, that's all we are assuming about it. Only the trains dictionary we are assuming it's already given, or is somewhere like trains dictionary computation is there in week 9 or somewhere.
Ma'am, in general, in questions, train number is mapped to the list of stations which train is passing through. Actually, trains data set was containing that.
But here you can see trains of T of start. That means start is a key and end
Yes,
is,
ma'am.
so it is a
That's what is the doubt, ma'am. Like before someone asked, how is start being computed? Like, is it first of list of stations?
yeah,
Like,
first of list of whatever list we have.
that's the confusion which is being created. It's not
Yeah.
written there.
Yeah, just let me see if the slides are available in trains dictionary computation. If the slides are available for trains dictionary computation. I'm finding. This is not there. This is not. Okay, this one only. Now we are saying. Week 9. This is not there. No real-time examples using working graphs. Where trains dictionary computation is it's mat graph creation. No, it's not there. So just assume for now, okay. Currently, I'm unable to get that slide for you because it's not there.
Okay, ma'am. No problem.
Yeah, if it is there, then I would have shown. Okay, this is our trains dictionary. So stations, now stations is an empty dictionary initially. What we are doing in this procedure, direct routes of train, that takes the trains dictionary. So in trains dictionary, we have all the train numbers and mapped to this one starting and ending station. So yeah, stations of trains of T of start, that will give the starting station name. So Kolkata equal to true. We are doing comma, and then what we are doing? then we are again the ending station Bikaner also we are making it as true. We are making it as true. So this is how we do for each and every train. For each and every train, we will get its starting station and its ending station. And that station we are mapping it to whatever station name we get, that we will make to true. Okay. So n equal to length of keys of stations. N equal to, this is n equal to length of keys of stations. So stations will have all the stations names, no? Stations will have all the station name of the starting and ending points for a train, of all the trains. So here Kolkata and Bikaner here, for other train number, the other station names will be there, no? So all the station names which are starting and ending station names of the trains, all the station names, all those station names will be there, which are the starting and ending stations. All the station names will be there in our N. N is the length of piece of stations. Similarly, you will get other station names also for other trains. Let us assume Delhi has a starting station for other train and its ending station is Bangalore or something like that. Let us assume. So this also will be there. So this will be like for all the train numbers, we will say it's a starting station and the ending station and map those values to true in the stations dictionary. And okay, you understood now what our stations dictionary has. Just a station name, which is a starting station of any train number and ending station of any train number, and it is mapped to true. N equal to length of keys of trains. Just this length of keys of trains. Only the stations. How many such stations names we have, that length. Direct equal to create matrix of n by n. So now we are creating, let us say we have 10, let us say we have 10 station names here. So we will create 10 by 10 matrix. Okay. After creating what we are doing, station index is another empty dictionary. Station index is another empty dictionary. I equal to 0 for each s in keys of stations. For each s in keys of stations, station index of s equal to I. So what we are doing here? Now we have some matrix. All elements are mapped to 0, 0 initially. Okay. And now we have station index as an empty dictionary. This is the iterator. In this iterator, for each station, we are giving an index. For each station, we are giving an index. So, for each SN keys of stations, what are keys of stations? Keys of stations are nothing but station names, right? Station names. So, for each station name, we are giving an index. So, initially starting with I equal to 0. For each S, we are incrementing the value of I by 1. So, for the first station name, the value of I will be 0. For the second station, the value of I will be 1. For the third station, the value of I will be 3. So, for these stations, we are generally, for each station, we are generally giving an index. So, let us say Kolkata, and that is given the value of 0. And in the station indexes is a dictionary. And Bikaner, and the value of 1. And Delhi, something like that, the value will be 2. Okay, this is how our station index dictionary will look like. So each station, for each station name, we are giving a value, we are giving an index in the station index dictionary. Okay, then what we are doing? For each T in keys of trains, we are iterating through the trains dictionary again. I equal to station index of trains of T of start. So for each T in case of trains, so I is an variable. I equal to station index. So we are getting the starting station and ending station of a train, and that is the value. See, that is starting here, trains of T of start, trains of T of end. What it will give? It will give the, what is our trains dictionary? Start is starting station name, and is ending station name. So we'll get the starting station name, and that is stored in the value I. Will get, that is station index of that particular. Okay, you are getting now. Here, trains of T of start, it will give a station name. It will give a station name, Kolkata. Okay. So station index of Kolkata. Here, this one. Station index of Kolkata, this is a dictionary of Kolkata, will give us the index value 0. Okay. And station index of trains, the ending station will give the station name, and we will find the index of that station name. So that is J. So here the ending station is Bikaner, and Bikaner index we got as 1. So we'll get in the direct of ij, in that matrix, direct of ij, we will map that value as 1. We'll map that value as 1. What we are doing, the pairs of trains which are connected by the direct trains, we are giving the value of 1. Understood, no? So what we done? So we know the station, the starting station and ending station are connected by a direct train of a particular train. For a particular train, the starting and ending station of that particular train are connected by a direct train. So what we have done, we have found, like we have first formed the stations dictionary. In the station dictionary, what we will do, we will map the starting station name to true and the ending station name to true. This is just to get the number of trains, number of stations that are at the starting or ending. Only to get that number of stations, because we have to create a matrix of such a size. Okay, we have, let us say we have 10 station names which are at the starting and which are at the ending. Like which can be at start or which can be at the end. 10 station names. So we want 10 by 10 matrix. So for this only we are computing the stations dictionary. Just we are computing what we are doing, we are getting the starting station name, that we are mapping it to true. Ending station name, we are mapping it to true in the stations dictionary. The purpose is to get the number of starting or the ending stations of any train we have. And after getting such stations, which are either starting or ending, we will form the matrix of that length. And station index is a matrix that will give index for each and every starting and ending, starting or ending station. For each and every starting or ending station, we will give index. Okay, in the stations dictionary. And after giving the index, we will just, using the trains dictionary, we will find the starting station and ending station, and we'll find the index of that particular station name, and we'll map that. We'll map the value of that particular value, like Bikaner and Kolkata value here. Let us say that row we are giving 1. Similarly, we will find the other stations also. We'll find those values, we'll map them as 1. Whatever the stations which are connected by the direct train, we'll map them as 1. So let us say,
Ma'am, I have a doubt.
yeah, yes, Marvika.
Why are you finding the index?
Because that is for mapping. If we create direct train, like direct matrix of 10 by 10. So for which things we have to give 1? Like initially all values are 0. Let us say 3 by 3 only for now, simplicity. 3 by 3. So for which thing we will take the parts also, trains also. Let us take 3 trains. Okay, Kolkata is starting station for 1 train, and Bikaner is also ending station. Okay, this one for 1 pair of train. And for the other pair of train, let us say Delhi, Bangalore. Okay. And other train, let us say Chennai, Bangalore. Okay. Okay. Now, what will
What does the index do
I
here?
will tell just. So this is what we have in our stations dictionary. In our stations dictionary, assuming that we have only 3 train numbers, for 3 trains only. Let us assume in our data sets we have only 3 trains. And for these trains, these are the starting stations and these are the ending stations respectively. Okay. So what our stations dictionary will look like? In the stations dictionary, we'll have, in the station dictionary, I will write this K for Kolkata, that will be mapped to true, and B for BIK for Bikaner, and that is also mapped to true. This is our stations dictionary. And Delhi, D, that is mapped to true.
Okay, and
Bangalore,
what does it mean when you map it to true?
we are just finding the starting station, ending stations by this.
Okay, if we map it to false?
No, we are mapping it to true because we know that if they are starting and ending station of any train, then that means they are connected by a direct train, right? They have the direct route. If you wanted
Yes,
to go from Kolkata to Bikaner, you can take the train, that particular train, 12259, so that you can no need to switch in between the trains. No need to switch. You can continue through the train. That will be the starting station and the ending station. The last station you will drop at Bikaner. So there is no need to switching of the train. Okay, that means they are connected by the direct train, Kolkata and Bikaner. Okay, you
Okay.
understand?
Yeah, ma'am, yeah. And then after that, the
We are
steps
finding the
after.
direct routes. We are finding the direct routes. Okay.
Okay, what
This is our
can you
stations
scroll a
dictionary.
little up?
So it will have this one. Chennai is also mapped to true in our stations dictionary. Okay, now we have to construct a matrix. Why we wanted to construct a matrix? We wanted to know which stations are connected by the direct trains. Direct. So we'll just create 3 by 3 matrix. Here, all of them, the indices will be 0, 1, 2, 0, 1, 2. And initially all values will be 0. All values is 0. Now what we are
Ma'am,
doing?
there are 6 stations, no? It will take keys of stations
Sorry,
dictionary.
so in the case the keys of that one, so there will be 6 by 6 matrix. But for simplicity, I am assuming like only 3 by 3 matrix. Okay. Okay, let us
Okay,
do.
ma'am. Okay, ma'am.
Yeah, that
Ma'am, there is a question.
yeah, yes, please.
This dictionary you have mentioned from station and to station, correct? Starting and end station.
Yes.
So
Yeah.
it is the same, it is look like, or else is there any train number as a key, right?
Yeah, train number is a key that is in the trains dictionary, not in the stations dictionary. Trains dictionary, I have already written what is there in the trains dictionary. Now, whatever I have wrote is the stations dictionary, not trains dictionary. So, stations dictionary will have only this one. So, stations of trains of T of start will give the starting station name, and the trains of T of end will give the ending station name. So in the stations dictionary, we have the starting station that is mapped to true and the ending station that is mapped to true. So we have only the station names that are mapped to the true. Okay.
Okay, so it contains only the starting and ending stations. That's it.
Only the start.
Of
So
all combined together.
yeah, all combined together. Yeah, all
Okay.
all such things. So now this is our matrix. And what station index is doing? Station index is like giving this number, index number to each and every station. So Kolkata 1, Bikaner, Kolkata 0, Bikaner 1, Delhi 2, Bangalore 3, Chennai 4. Okay, Chennai 4. So we have only 4 keys, no? 4 keys because Bangalore is repeated. 0, 1. So 4 by 4. How many? Kolkata, Bikaner, Delhi 3, Bangalore. 5 keys we have. So we'll have only total 0 as we are starting from 0. So we want only 4 by 4 matrix. That is 3, like 4 by 4
So
matrix.
5 means 0 to 4.
Yeah, 5 means 0 to 4. 5 means 0 to 4. So here how many we have? 1,
3
2,
only we have.
4, 5. See, 5 we have. But we want one
No.
more.
Yeah, one more we need, right? So you have to insert one more 4. Yeah.
So let us write here also. 0 is for Kolkata. 0 is for Kolkata. That is what our station index is doing. It is giving the value, index value for each and every station. So in our matrix, what are our rows? Our rows are nothing but 0, 1, 2, 3, 4 only. 0, 1, 2, 3, 4. What station index is giving? It is giving the index value for each and every station.
Station.
Yeah, station. So
Yes.
Kolkata, it is giving 0. For Bikaner, it is 1. Bikaner, it is 1. For Delhi, it is 2. For Bangalore, it is 3. Okay. For Chennai, it is 4.
Chennai
Chennai, it is 4. Okay.
4.
So there will be one more here. Chennai, it is Chennai here. So same thing here. Kolkata, Bikaner, Delhi, Bangalore, Chennai. Okay, this is how our matrix will look like. Matrix will have 0, 1, 2, 3, 4 only. Just for understanding purpose, I have written there. Okay, fine. So now what I am getting? I am getting the starting station and ending station of that particular train. For all train numbers, we'll get the starting station, ending station, finding the index of that station and mapping that. So this will give now starting station index of Kolkata will give the value of 0. Here, station index, here Bikaner is the ending station for the particular train, will give the value of 1. So direct of ij equal to 1. So direct of 0, 1. At the place of
Ma'am,
0th row, first column. 0th row, first column, I will make it as 1 now. Okay, because they are connected. Kolkata and Bikaner are connected by direct train. So I am giving the value of 1. Okay. Same thing for the other train. For Delhi and Bangalore, Delhi row and Bangalore column. Delhi row and Bangalore column. Where is Bangalore here? This one. So Delhi row, Bangalore column. This one, third one, I think. will give 1. So this is what we are doing in the map. So whatever the stations which are connected by the direct train, we are making the value as 1. So for Chennai and Bangalore, will give the value 1. Chennai and Bangalore will give the value 1. So this will be repeated. This will be repeated now because we will iterate through the to these trains for the each and every train. Right? Kolkata, Bikaner we got. Delhi, Bangalore, Chennai, Bangalore we got. So IJ we got as this one. And yeah. So the corresponding values we will get 1. Only these values will be 1. So by this we know that this train Kolkata and Bikaner are connected by graded train. Whatever the state, whatever in our matrix, whatever the values that has 1, that means those stations are connected by the direct train. This is what the procedure is doing. Okay, is it clear? Just we found the starting stations and ending stations for each and every train. For those values of the stations, we are giving the 1. For all such stations which are either at the starting or ending, we are just giving them true in the train, in the stations dictionary. This is just to get the length of our this one graph. Like how many
Ma'am,
yeah,
ma'am, can you go to that pseudocode?
yes, yeah.
For each key in keys of trains, then we are for that particular train, if that starting station and ending station,
Yes.
it's there in STN index.
Hmm.
Then we will go to that particular index number
Index.
of that train and we will do the value 1.
Yeah, for particular index of that matrix
Oh,
directly.
matrix, ma'am. Yes, ma'am.
We'll
Matrix.
give that value 1. That means the both stations are connected by a direct train. Okay. Got it? Here
Okay,
we
ma'am.
have only these 3 trains, no? Kolkata, Bikaner, Delhi. So how many stations we have? 5 stations because station name is repeated. So we form 5 by 5 matrix, and whatever that station name we are saying starting and ending, those stations we will map them as 1. For all other values, it will be 0 because Bikaner is not directly connected by Kolkata because we can reach from Kolkata to Bikaner, but directly if we sit in the Bikaner train, can we go to Kolkata? No, that is not guaranteed, right? We know.
So this is a directed graph, right, ma'am? This
Yeah,
is not
this
an
is a
undirected
directed
graph.
graph. This is not undirected graph. But if you see our trains data set carefully, for each this kind of train, each this kind of pair, there will be opposite pair also. Like if 12259 goes from Kolkata to Bikaner, other train number will go from Bikaner to Kolkata in our trains data set. Okay, because generally in these trains also, like generally we can see like if one train goes from Delhi to Bangalore, while returning it will go from Bangalore to Delhi only, no? Yeah, the same train number. Some, right?
Yes,
Ma'am, then
yes. The
this
Yeah.
should
same
be
train will come back.
undirected, right? Because
Sorry.
a pair of train is already always available, ma'am. From going to one station to the other, we have just the last digit of the train number changes and we can
Yes,
come
something.
back.
Yeah, we can come back. But the thing is, in our graph, this is a directed graph. If we can go from one station to another station, we will show it as by 1. This is directed. So that means Kolkata to Bikaner we can go. That is 1. If we wanted to go from Bikaner to Kolkata, that means we have to show this value as 1. So that is also there. That is also will be there. That values also you will come if you see the trains data set, and if you just take the 5 cards and you can work, then you will understand it better, I guess. Is it possible?
Can you scroll a little?
Yeah.
Can you
Ma'am, I
scroll
think
a little up?
not call it as a directed graph because every time if I'm going from Kolkata to Delhi, I can come back from Delhi to Kolkata.
Yeah, Delhi to Kolkata. Yeah. That is also there. The return train is also there. That's why you will get that value.
So that means, ma'am, we'll not call it as a directed graph, right?
See, because we are, if there is route from Kolkata to Bikaner, then only we are mapping it as 1 here. If there is route from Bikaner to Kolkata, then here we are mapping it as 1. Okay, while doing, we are keeping the edge. Like if it is 1, that means there is edge from Kolkata to Bikaner. That means we can go from Kolkata to Bikaner. From Bikaner to Kolkata, if we are able to go, then we have to keep this value 1. That means we are doing in this way, no? So that means it is a directed graph. If we found only Kolkata to Bikaner, if there is some, okay, if there is if there is edge from, if Kolkata to Bikaner, like 0 to 1, there is edge. We are not doing like, here we are not writing here direct of ij equal to 1, and then we are not doing direct of ji equal to 1 also we are not doing. If we do direct of ji also 1, that means it will become undirected. Here just if there is, if we found starting and ending station, we are just drawing edge from starting station to ending station. We are not drawing edge from ending to starting station. So direct of J, we are not making one here, no, here itself. So it is directed. Here it is directed. If we do direct of Ji also 1, then it will become undirected. That means if it is possible to go from I to J, then it can be possible to go from J to I. Generally, through our data set, we know this is like if there is edge, if we can go from one station to other station by a train, then returning also possible. But
However, the data set,
Yes.
if they given, so
No.
entire data set of train data set, if they were given only, it is possible. Otherwise, the pseudocode will work. Whatever the data set you are passing through the data of the pseudocode, that only will work out.
Yes.
So it is there defaultly it will not take the direct and I mean opposite train. Yes,
Yes. By default, it is not
it will
undirected.
not take.
Data set
Yes.
is directed, like our data set, we have that kind of pairs, opposite pairs also will get undirected graph. But basically, if our data set, if we pass some opposite trains, if they are not there, opposite station names are not there, then we'll get some undirected, like directed graph only. Okay.
Yes.
Yes, ma'am. Got it.
Is it clear now? This direct routes question.
Yes.
Ma'am,
That
the
means, ma'am,
pseudocode, can you just go with?
Yes.
So this pseudocode, the last step and all, okay, fine. So when you're starting from 4th and 5th step, and we are taking the length of the key stations. The stations are like whatever the station we are taking out, for example, Hyderabad, whatever. So from there, actually, from there to before that for loop, it is like confusing for me. Till this I equal to I plus 1. That is what we are doing over there.
For each, now we have only station names and mapped them to true. Like station names Kolkata, Delhi. But in the map, in the matrix, what we will have? In the index will have the values of 0, 1, 2, 3. So we should map our station names to such values. So how that is done? We have created for each station.
One more dictionary.
Yes, like we're starting from 0. We are iterating through the
Okay.
list of stations and we are giving index value through each and every station. So starting from 0 to I plus 1 number of stations we have in our dictionary.
Okay. Okay.
For Kolkata, we are giving 1. For Bikaner, Kolkata it is 0. For Bikaner it is 1. For Delhi it is 2. Chennai it is 3. Bangalore it is 4. Something like that we are doing. Okay.
Got it. Yeah.
And then we are going to the trains dictionary, just getting the starting station, ending station, and the station index of that particular starting and ending station, that is ij. In the matrix, in the matrix, we are mapping that value to 1. That means we got starting, ending, and that station we are drawing an edge from that starting station to ending station. Okay. This point. This
Okay.
is
Okay, ma'am.
one hop routes. So station A and B such that you can reach B from A by changing one train. So one hop means one switch. So like if we are able to go from Kolkata to Bangalore by switching a station, by switching a train, by one train. So let us say you have to take 12259 and 122 some 63 some train. If you wanted to do that kind of switch, this train goes from Bikaner, Kolkata to Bikaner, let us say this goes to Bikaner to Bangalore, something let us say. So if by using one switch, like one train transfer, one hop, by taking one hop, if we are able to go from station A to station B, then that means one hop. Station A and B such that you can reach B from A by changing one train, that is called one hop route. One hop route. Previously, it's like direct train, no switching. Here, one hop route means if we switch from one train, if we can go from one station to another station by changing one train, then it is called one hop route. So we have to find one hop route using this procedure. using the procedure. So yeah, we are assuming it like in the one hop route. So all the trains which are directly reachable, right? That also, by using that, can we get one hop route? See, if we can go from, we have already seen, we can go from Kolkata to Bikaner, okay, Delhi to Bangalore, and Bangalore to Chennai, okay, Chennai. So if we wanted to go from, Delhi to Chennai, we can take this switch, no? We can take this like one hop. So direct off here, so it is, let us say, the value here it is, let us say 2, 3, and here it is 3, 4. So if we have direct train, if direct of 2, 3 equal to 1, and direct of 3, 4 equal to 1, and direct of 3, 4 equal to 1, then what we can say, direct of T4, like one hop of T4, one hop of 2, 4 equal to 1. That means we can go from Delhi to Bangalore. One hop route is equal to 1. We can make from Delhi to Chennai as 1 because we are making one switch. You understood now whatever I wrote? If we can go from directly from Delhi to Bangalore and from Bangalore to Chennai, we can go from Delhi to Chennai by taking one hop route, like one train. That's what here, this condition here.
We can see now at least one common station in both trains.
There should be at least one common station between
Yes.
the two
Trains.
Yeah, there should be at least one station between the two train numbers. Okay.
Can you just draw this matrix of K where it will place in as a column so that from there to we can switch it?
So just see this procedure one hop of direct. It is taking direct matrix. Okay. N
Yeah.
equal to length of keys of direct. So we are taking the
Direct train matrix.
length only. Yeah, direct length of keys. Like that
Yes.
matrix only we are forming. One hop equal to create matrix of n by n. For each I in rows of direct, for each j in columns of direct. What are those rows and columns? They are nothing but 0, 1, 2, 3. But in the station index, we have mapped 0 as some Kolkata, 1 as Bikaner, 2 as Delhi. That thing mapping we have done. So for each k column, k in the columns of direct, if direct of ik equal to 1 and direct of kj equal to 1, then we can say one hop of ij equal to 1. The same thing I have written here. If we can go from Delhi to Bangalore directly and Bangalore to Chennai directly, we can go from Delhi to Chennai by taking one hop. So the same thing here. If there is one common station between I and J, between the I and A, Delhi and Chennai, if there is one common station, that means we can go by taking one hop. So directly for some routes, like we cannot go directly. We have to like switch from one train to another train.
Yeah, that is okay. And the J column where it will place and the I column, K column where it will be.
Yeah, it's that
The
thing.
row if I fix it.
Through the rows and columns. In our matrix, we are iterating through the 0, 1, 2, 3. We are iterating through this. So if we can go from Kolkata to Bikaner directly, we have mapped here 1, right? If we can go from, if we can go from Delhi, let us say 2, Delhi to Bangalore, like here, Delhi is 2 and Bangalore is 3, let us say, we have made it as 1. Chennai is 4 now, Chennai is 4 here. So, and then what we are doing? Okay, let me
write it clearly. Yeah.
Yeah. This is not required. Here, this one.
Yeah, ma'am, no issues.
We have direct matrix 1, 2, 3, 4. So 1 is for Kolkata, 0 is for Kolkata, 1 is for Bikaner, 2 is for Delhi, 3 is for Bangalore, and 4 is for Chennai.
Chennai.
Yeah, 0, 1, 2, 3, 4, same thing. Kolkata, Bikaner, Delhi, Bangalore, Chennai.
Chennai.
Okay. Now we can go from Delhi to Bangalore directly.
Yes.
We can go from Delhi to Bangalore directly. Here it is 1. And
Yeah.
Bangalore to Chennai directly here.
Yes.
Yes, no? Bangalore to Chennai directly. So that means here what we are doing, but for each I in rows of direct, this one, for each j in columns of direct, this one, if that for each k in columns of direct, that means what we want to check there is some common station between I and j. Between I and j, whether there is some common station. Here you know whether if it is rows or columns or anything. Even if you say rows or something here, it won't be worry because the rows and columns values are nothing but
Yeah.
0 and 1. But the
So
thing,
that is what I'm confused. It is mentioning column, but we have to go to the jth row and we have to check the column of last any whichever the station we want to go. It is mentioned as column. That is what I'm confused.
this one for each k in columns, this line confusing for you.
Yeah.
Yes, ma'am.
Because both the column
Ma'am.
we are checking, right?
Let's iterate through this row 2 and 3 so that we can understand.
Yeah. So let us do. Okay. For each I in rows of column, for each j in rows columns of direct of ik should be 1. Direct of ik should be 1 and direct of ki equal to 1. Okay, what is our k here? K is also some number. Like, okay. Initially, what is the I value? Let us do iteration by iteration. Kolkata to Bikaner is 1. We'll write it as 1. And Bikaner to Kolkata also, we will have 1. Okay. Delhi to Bangalore is 1. And Bangalore to Delhi also will have 1. Bangalore to Delhi will have this one here also 1. Okay, Chennai. Bangalore to Chennai. And Chennai to Bangalore also we can go. Chennai here. Chennai.
Oh, this is again confusing. So the return.
Yeah. Now let us see. The values here is 0, 0, 0, 0. So you can see here. So from Kolkata, we can go to Bikaner only. We cannot go to any of the things, any other stations.
Correct.
Yeah, from Kolkata, we can go only to Bikaner. From Bikaner to, we can go to Kolkata only. We cannot go to any other things. So remaining things are 0. That's all. Okay. From Delhi, we can go to Bangalore only. Okay. From Bangalore, we can go to Chennai. Right? From Bangalore, we can go to Chennai. And we can go to Delhi also. From Bangalore, we can go to Chennai. Here it is 1. And we can go to Delhi also. This row should be 1. Okay, from Chennai, we can go to Bangalore. Right? From Chennai, we can go to Bangalore.
Yes.
Okay. You understood this matrix now?
Yeah, because I understand. Yeah, Bangalore is right now. Sorry, Chennai train to Bangalore is K right now.
So we like for each I in rows of direct. So I value is fixed. So we'll go 0 at this one, 0 at row. For each j in columns of direct. So j is also fixed 0. And we are finding the intermediate k, that thing. From 0 to 0, can we go from Kolkata to Kolkata by taking one intermediate station? Not required, no? So for each k in columns of direct, this one, the inner loop first iterates, no? The inner k value will be changing. The inner k value will be 0, 1, 2, 3, 4, so on. Right? So for if direct of 0 to 1, 0, so we will see if direct of, we have to go from 0 to 0, right? 0, we have, like what we are checking, 1 half of ij equal to 1. What is our y value? 0 and j value is 0. Like can we go from Kolkata to Kolkata, like 0 to 0 by taking 1 half? It should not be false, no? It should be false because
No,
it's
cannot
not
take it.
required. So what we are doing, direct of I is, the k value in the first iteration is 0, 0. If 0, 0 equal to 1 and 0, 0 equal to 1, no, it is false. Nothing will happen. And the other thing is 0, 1 if it is there, and 1 to 0, whether it is 0. Let us see. 0 to 1 it is there, 0 to 1 it is 1, and 1 to 0 it is 1. But J value should change. No, J value is not changed. J value is just I and J value is nothing but 0, 0 only, right?
Yes, then 0, 0 should be 1.
Yeah. Let us do 0, 2 and 2, 0. It is 0 only. No one hop. No one hop. Just take the practical case here. Delhi, Bangalore, and Bangalore, Chennai only we have. So what is the index value of Delhi? Delhi index value is 2. Delhi index value is 2. And the bank, what is our
Ma'am.
J value? What should be our J value? J value should
Ma'am.
be Chennai value. So we should be able to go from Delhi to Chennai. So 2, 4, the value of 2, 4, Delhi to Chennai, right? Delhi to Chennai should be 1. How we should do? So first I value is fixed. I value is fixed 2. Let us take 2. And J value is also 4. We must be able to do that, right? For each K in columns of direct, K will be going from 0, 1, 2, 3, 4. So direct of, we'll check 2, 0, whether it is 1.
2 to 4 it is 0.
2 to 4 it is 0. But can we go by using one hop? That's what we are doing. Okay, 2, 0 is equal to 1. No, from Delhi to Kolkata, we cannot go. And Kolkata to Chennai, can we go? No, we cannot go. From, that's what, K value will be changing. No, K value is starting with 0. K value is like for 2 and J value is 4. K value will be changing to 0. First time is 2, 0. So the 2, 0 means Delhi to Kolkata, can we go? No. From Kolkata to Chennai, can we go? No. So the both values are 0. So it will one hop of ij will be not be one set. And next value of k will be 1. So the next value of k will be 1. What is the value? 2, 1. 2, 1. 1 is nothing but Bikaner. So Delhi to Bikaner, can we go? And Bikaner to Chennai, can we go? No. That is also not 1. So no, one hop of 1. We won't make it to 1. So third thing is Delhi to Bangalore, can we go? Third is Delhi to Delhi only. So Delhi to Delhi is 1. Like Delhi to Delhi is not 1. No, it is not 1. It is 0 only.
Delhi to Bangalore only 1.
Yeah. Delhi to Bangalore is 1 and Bangalore to Chennai is 1. So only at that case we will make Delhi to Chennai as 1. So if there is some common station, some common station between I and J, then only we can make one hop as 1. Right? There is some common station between Delhi and Chennai. Bangalore is the common station. But for what value of k we got? The value of k is nothing but for what value of k? 3.
Bangalore.
Yeah,
Bangalore.
Bangalore.
Ma'am, I think we have to create another matrix for one hop, right, ma'am?
Yeah, we have already created. For one hop, there is another matrix. One hop equal to create
No, we
matrix.
don't want to create matrix for one hop. It is the key. I mean the
No,
between I
One
and
hop is
J
separate,
column.
one hop. This is direct matrix. In order to form the one hop matrix, we are checking the direct matrix. Whether we have the common station between two stations. If there is one common station between those two stations, then we can go from that starting station to ending station by taking a switch. Okay. If there
In
is
this for each loop, ma'am, for each k in columns direct, for that k, where is the value is coming? It is the intermediate, middle station, but how we are accessing that value?
So K is nothing but columns of direct matrix. Now, what are the columns of your direct? It is nothing but 0, 1, 2, 3, 4 only.
I and J are
Also 0, 1, 2, 3, 4 only. But each 0 corresponds to some station name and 1 corresponds to some other station name. We are checking whether there is some direct train between I and J. If there is some common station between I and J, then we can go from I to J by taking one hop. If we can go for, see, I and J, you can see direct of IK equal to 1 if they are starting and ending station of a train, right? But if we wanted to switch the train, if we wanted to, if we can switch a train and go from one station to other station, that means there should be one common station. So when we can switch here, like, okay, you have to go, same example, Delhi to Chennai. There is no direct train. But how you will go? Delhi to Bangalore is a station. You can go take one train, and from
Ma'am, that
Bangalore you
is,
can take another
yeah,
train.
that is
Right?
everybody
But
understood.
there
And
is some common
Concept is
yeah.
station
clear,
between
ma'am.
Delhi
The
and
thing
Chennai.
is, there are 3 loops, like for each I in rows and for J in
Yeah, for
column.
K is this third iteration is for finding that common.
So where is that values? As we are saying, for each I, we can take it from the matrix, right? For
Yeah,
J,
you are taking from the matrix of direct only.
so J, we are taking the columns, right? The column number like that. So where is K? From where
These
we are?
also the columns of direct matrix only. See, IJ is nothing but they are indices of your matrix. The index of the matrix are nothing but 0, 1, 2, 3, 4. Even if you say rows or columns or anything, it doesn't matter. But the thing is, you have to find our motto is like, I can go from station I to station J by taking one hop if there is some common station in between them. Okay, some common station between them means some intermediate station. So if I can go from I to K and K to J and K to J, that means one hop of Ij equal to 1. So K is nothing but the intermediate station. K
So in whichever station I, J, we are finding there is a connection that we are considering as K and moving ahead, right?
Yes, K is so I, J, K, everything are nothing but 0, 1, 2, 3, 4 only. They are indices of your matrix only. We are just iterating through the matrix and we are finding that common station. So K value will change from 0, 1, 2, 3, 4, the length of your whatever the trains. So for each, for every IJ, for every pair of IJ, we are checking whether there is some intermediate station. Okay. The
Ma'am,
K
that is
value,
understood.
yeah.
So I can able to answer, I think, what she asking. So the
Yeah.
thing is, for each I row and J in column and K in column, okay? Just leave it aside. So what here actually D2, that is Delhi, and Delhi to I'm going to Chennai. So in between there is a Bangalore. So what it will do? It is I is right now my Delhi, and K is the column which is Bangalore. So Bangalore will become right now K. So after that K as a row and J is a column. The J is my Chennai right now. So both are equal to 1 and 1/2 is equal to 1. Understood?
Yeah.
That's it. So actually here the K right now will become as a row because you check the K as Bangalore row and check as a,
So K
So
here.
in between the program, we are considering like that. There is no direct interpretation like I and J in a matrix can have only 2 index, right? Row and
The
column.
matrix can have
K,
only indices, but we are iterating through, we are checking for that intermediate index.
it is just like J, we are mapping like K if there is an intermediate station and we are checking with that.
See, you are checking
Alright.
here direct of IK and direct of KJ only. Like you are not taking third index. You are not taking the third index. No, you are not
Ma'am,
taking JK. Yep. Just
ma'am,
we are
can you
having K
take
values.
that row index, fix it as 2 and column index as 5 and then iterate to K? It will be more clear.
Yeah, that's what I have shown here also. I is like previously Delhi to Chennai we thought. No, I is Delhi and 4 is Chennai and K is like Bangalore. So K will varies every time. So we are iterating, while iterating K value will go from 0, 1, 2, 3, 4. Okay. So first case, whether we have direct of 2 is to 0. First K is 0, right?
No,
So
ma'am.
2 0, whether it is 1. No, right? Delhi to Kolkata, we don't have any. So this condition we can skip. And the second case is like 2, 1. Delhi to Bikaner, can we go? No, we cannot go. The edge is not there in the direct matrix. 2, 2. Delhi to Delhi, no edge, no. Delhi to 2, 3. What is 3? Delhi to Bangalore, yes. Delhi to
Yes, ma'am.
Bangalore we can go. And whether J value is 4, you know, like J value is 4. I is 2,
Yes, ma'am. Yes.
Yeah,
K is 4. So here 2, 3. K is Bangalore, 3. K is 3. Now 3, 4. J is 4.
3,
correct,
So
4,
correct.
can we go
1.
from Delhi to
Correct, ma'am.
Bangalore and Bangalore to Chennai? Yes. Then we have edge in our matrix. So you can
Hmm.
see Delhi to Bangalore there is edge, and Bangalore to 3, 4 there is edge Chennai. So if there is edge, then what we can do? We can make edge in one hop matrix. In one hop matrix, the same length 0, like 4 by 4 matrix. We will make 2, 4. Like one hop of 2, 4 equal to 1. That means Delhi to Chennai. We can go from Delhi to Chennai by taking a hop. 2 something 4 here, let us say. So that value will be 1. Here basically you can see here we don't have 1. From Delhi to Chennai we don't have edge. But now how we are creating an edge? By seeing whether there is some common station between Delhi and Chennai. Yes, Bangalore is a common station. If we can, right, we have that intermediate K. So K is becoming column here and row here. You can see
Correct, correct, ma'am.
yeah,
Yeah, ma'am.
one time it is ending station and other time it is starting station.
Starting session, yes. Ma'am, I request you to kindly to give the example. Whatever you written, the matrix is not clear, ma'am. It is like clumsy. It is like, look, kindly next time just write it neatly, ma'am. Thank you, ma'am.
Ma'am, I guess we can say it's like a transitive case over here. If A comma B is
Yes,
there and
yeah.
B comma C is there, and so it's possible to have A to C. Can we say like that?
Yes,
Okay.
transitively. So that means we can, if we can go from Delhi to Bangalore and Bangalore to Chennai, if we can go, that means we can go from Delhi to Chennai by taking this switch in Delhi. Okay.
So here for each loop, we are taking 3 variables, I, J, and K. J
Yes.
and K both are columns. So in between, we are checking the row with the K and KJ like that. And as per the answer, as we are getting the result, we are finding out the middle.
Yes.
A is becoming starting station and ending station. Here it is direct of IK means it is ending. Here it becomes start. Whether it is starting and ending station of any train, of trains, we are checking. If it is becoming, then that is a common station between the two stations. And then we can take a switch. Yeah.
Okay, thank you.
Okay. So that is one hop route. That is one hop route. Within one hop means, can we go from station I to station J, either by direct train or using, like within maximum one hop we can take. That is within one hop, either directly or by one hop. That is within one hop we can go. The procedure does that. This procedure does that. Within one hop, can we go from station I to station J within a hop? Like you can go in directly or can take a hop. Okay. Station A and B are such that you can reach B from A by changing one train. Okay, I tried through intermediate stations. Said one hop of IJ equal to 1 if there is connection via intermediate station K. More useful to let one hop of IJ mean connected with at most one hop. So connect one hop of IJ, if you say equal to 1, it is more useful to say one hop of IJ mean connected with at most one hop. At most one hop means either directly, either no hop, or you can take one hop. So initially one hop matrix you are directly one hop equal to create matrix of n by n we are doing no. And while assigning the values, you are telling one hop of IJ equal to direct of IJ. That means wherever there is edge in the direct of ij, the same edge will be there in the direct one hop of ij. And if we can find an intermediate station, there also we are making the one hop of ij equal to 1. Okay, that means we can go from station I to station j with no hops or with one hop, with at most one hop. Then this is within one hop, or yeah, it is more useful. Later sir has modified telling that either you can go one hop is either you can go directly or by using at most one hop. That means no hop or
Ma'am, does this mean that if there is a train from Delhi to Chennai directly, or we can go from Delhi to Bangalore or from Bangalore to Chennai, like both are equal, like we can do any one of them. Is it true what I said?
yeah, if we go, yeah, that will be shown in our one hop. Yes.
Okay, ma'am. So in one hop matrix, it will update. Like from if there is a
Yes.
train from directly from Delhi to Chennai, also it will update, or
Yeah.
only with one hop also it will update.
Yeah, one hop also it will
Okay,
update.
ma'am.
Yeah,
Okay.
that
Ma'am,
is yes, please.
can you, yes, ma'am, in previous we just created the one hop. Here what we are doing that first we are storing that direct matrix in one hop, and
Yes,
then we are checking for one hop case also. That
yes,
direct is already there in one hop, and now we are including that one hop case also. So it
yes,
is at most one hop or direct, both are included.
yes, yeah.
Okay, ma'am. Okay, ma'am.
So in previous, we are updating the direct matrix to like from 2 to 4. Before it was 0. Like
Yeah,
the edge was 0. Now we are making it to 1, right?
yes,
Correct, correct,
Okay.
correct.
Okay. We are having the other cases also. We are
yes,
just
yeah.
updating from 2 to 4 equal to 1. Okay, ma'am.
One,
Thank you.
yes, yeah, yeah.
Hey,
That
ma'am.
is, yeah.
Ma'am, I also have a small doubt. This line which is given procedure with one hop, and we are giving this direct matrix as its parameter. So, uh, like, what does this mean? We are actually storing the all values of direct matrix into this one hop matrix.
Yeah. So
But
in
it
order to
is,
get one hop, in the previous case also direct matrix we want, because we
yes,
want
ma'am.
direct matrix only we can check. We are checking now whether there is intermediate or not. So we want direct anyhow. Direct matrix we want first.
So that means, ma'am, when we are passing this direct matrix as our parameter in this particular one hop procedure, so we are, like, what does this mean? Like, why are we passing this direct matrix? Because we are checking the values with the direct matrix. That's why we are doing this.
We want direct values. No, if we can, that's what we are doing. In the
Uh,
direct matrix, it stores whether we can go from station I to J station directly. If it is directly, then the value of ij will be 1. Okay. If we
so
can,
therefore, it is
yeah,
necessary to pass this direct matrix into our this procedure
yes,
because we
it
are
is necessary. It is necessary to pass direct because we want direct matrix is the reference where we are looking
okay.
whether we, yeah,
Yes, ma'am.
yeah, for two hop, if we can go from station I to J by taking two hop, that means one hop of ij and one hop of jk equal to 1, then two hop of ij we can make to 1. That's what we want, one hop at that time. So two hop is same, that means generalizing. Two hop, like two hop means station A and B such that you can reach B from A by changing at most 2 train, like 0 trains or at most 1 hop. Like you can go directly from ij or directly from ij by taking 1 hop.
One hop.
Directly if you can go, or by taking 1 hop, or by taking 2 hops. Like if you can go from ij by taking 2, by changing 2 trains, that is considered in 2 hops. So in the 2 hop case, if you can go directly, that then also it will be 1. If there is one intermediate station and if you can switch a train, then also a 1 hop of ij will be 1. If there is some two intermediate trains, if there are two intermediate stations, and if you wanted to switch the 2 trains, in that case also it will be 1. So direct of ij will be 1, one hop of ij will be 1. And if there is like two stations, two common stations, and also if you wanted to switch the 2 trains, then 2 hop of ij equal to 1. Okay, here you will pass 1 hop. Here you can see here direct and 1 hop matrix you are passing, and just getting 2 hop equal to create matrix of n by n for each I in j in columns direct. You are making 2 hop of ij equal to 1 hop of ij. And for each k in columns of direct, we are just saying if 1 hop, okay, if 1 hop of ik equal to 1 and direct of kj equal to 1, then, okay, that means 2 hop of ij equal to 1. Just we are checking, 2 hop means 2 trains we have to switch. 2 trains we have to switch. Okay, from 1 hop, you know, right? We can go is from station I to station J by taking some K intermediate station. Okay, 2 hop means some other station also you want. Okay, some L. 2 stations
Ma'am,
switch.
2 hops ij equal to 1 hop ij.
Hmm.
What is that? Is mean?
2 hop of that means at most 2, no? At most 2 hop. You can see here the definition of 2 hop. Station A and B such that you can reach from B to A, from B. You can reach B from A by changing at most 2 trains. At most 2 train means without any change or with 1 hop or with 2 hops. You can change either no trains or 1 train or 2 train, at most 2. Okay, that means all the values of direct of ij and 1 hop of ij should be 1. So that's why 2 hop of ij equal to 1 hop of ij with at most 2 hops. No, like at most 2 means either 0 hop, no hopping, or 1 hopping or 2 hop. That's why 2 hops of ij equal to 1 hop of ij we are making.
Ma'am,
Yes,
hello.
please. Yeah,
Ma'am,
yes.
this 1 hop ij is at most 1 hop ij means it's containing the direct case and at most 1 hop case both.
Yes. So that's why we are assigning, no, we are not telling 2 hops of ij equal to direct of ij and 1 hop of ij we are not doing. Directly 1 hop of ij we are doing. No, that's fine.
So it's containing both of the previous
Yes,
cases,
both of the
direct also and 1
and
hop
1 hop
case
of.
also.
Now we have
Okay,
to
ma'am.
find
Okay.
only for 2 hop case. Only for 2 hop case. How you will get 2 hop? 1 hop plus
1
another.
hop plus direct.
Direct. 1 hop plus direct. That will give the 2 hop.
Ma'am, here I would like to ask, like we are updating the values into hop case where at most we can change 2 stations. Like if
Yes.
from Delhi to Hyderabad we have to go, from Delhi to Mumbai we can go, from Mumbai to Kanpur, there from Kanpur to Hyderabad we can go. We'll update from Delhi to Hyderabad as 1 in that
Yes.
case.
So, okay, I will explain.
Here I would like to ask one thing, ma'am.
Yeah.
How do we know, like, if we are updating Delhi to Hyderabad as 1, where 2 hops are being taken, how do we know that we are going to Mumbai then Kanpur? Like, we don't have any, like, which stations we are visiting, we don't have any sort of list, right? Like, directly we're having 1 over there.
1 hop.
Again, for this matrix, if you return and tell in teachers only, it is understand.
In previous case also the same, from Delhi to Chennai
Yeah,
we
let
can go,
us
then we are updating that.
Delhi. Yeah.
We are not
So let us
telling.
see Delhi to Hyderabad case. Delhi to Hyderabad case. The same example I will do. So how can we go to Delhi to Hyderabad? Let us say Delhi to Bangalore we have to go first. And then Bangalore to Chennai. Okay, they only this one. Chennai and then Chennai to Hyderabad. We have to do. Okay, Chennai to Hyderabad. So now how many trains are we taking? So this is first train, this is second train, and it is train 3. Like how many trains are we switching in between? You are starting with 1 train. This is first train, and then this is your second train, and this is your third train. But how many times you are switching the train? Here and here only. You are switching 2 trains. That means you are hopping 2 hops. You are doing 2 hops. Okay. You are switching here 1 train and you are switching other here. So how many trains? Totally two trains you are switching. Okay.
2
Ma'am.
intermediate trains you can see.
Sorry?
Ma'am, one doubt, ma'am. Ma'am, this 1 hop ij is the initial hop which we created or at most 1 hop? Because if you consider the at most 1 hop, in that
Not
direct case will also
within 1 hop, at most 1 hop.
within. Okay, ma'am. Means 1 hop we
It will
should
include
take.
direct and also 1 hop case.
But if we include direct case also in that, ma'am, if
Yeah.
one hop ij, suppose their direct case will come, and again we are checking for direct, then that will be only uh, one hop, no, ma'am.
Right.
Could you please repeat your question?
Suppose in one hop, we are checking for two hops. So in one hop case, also direct case comes. So there we will get one. So we both the time we will check for direct only.
You're talking about the red part, which is highlighted.
Yes, yes, yes.
Here, the red part is including one hop and direct, because if both are one hop, then it will become three stations, I guess, over there. Like one hop contains already one station, right? Which we are going like back from Delhi to Bangalore. It already includes Delhi to Chennai. It already includes Bangalore as one intermediate station, and direct train will have no station. So two over there will be added. I hope
No,
you
no.
got
One
it.
hop
Okay, okay.
contains both.
Manish, my doubt is that in one hop we have direct case also, right?
Yeah.
So suppose if you are checking one hop IK, and in that you are considering that direct case. Suppose I and K are direct train, so that will also get true. And from K
Yeah,
to J also you have direct train. So that will be one hop case. Automatically it will become one hop case, right? Because
yeah,
in
no
middle.
problem. Now it's at most two hops. Like if there is a
Okay,
train from
okay,
Delhi
okay.
to Hyderabad,
Okay,
we can
now I
go
got it.
directly.
Okay, okay, correct, correct,
I
correct.
hope you understand. Like it's like
Okay,
becoming
I got it.
subsets.
So it's within the at most two hop subset. Okay, okay.
Yeah, at most two hops. You can reach directly, or no hop you can take, like that means direct, or one hop you can take, or two hops you can
Okay,
take.
ma'am, got it, got it.
Yeah, now let us see this. Delhi to Hyderabad, if you have to go, like you have to switch these two trains here, these are the switching points. You have to switch here, and you have to switch two hops you should take. Okay, compulsorily. So you will check the K value is, let us see the K value. What is the common station here? Common station, one hop, you have already seen one hop of Delhi to Chennai is one. Delhi to Chennai is one. So one hop, here Chennai value is the previous case, the value of 4, no? One hop of, you are writing one hop of Delhi is, the value of index is Delhi is 2. And let us say Hyderabad is 5. And K is 4. That means Delhi. So Delhi to Chennai is 1. And you can see direct of K. K is nothing but your 4 and J is 5 equal to 1. So you will make 2 hop of Ij equal to 1. Here what you will do? 2 hop of. So just we are finding whether there is a direct hop, whether there is, like you can go directly, and if you wanted to switch, then 2 hops of Ij means nothing but 2, 5 equal to 1 you will make. So what you are doing, if you can go directly, Delhi to Bangalore is already included in direct of Ij will be 1. So Delhi value is 2 and Bangalore value is, let us say, 3. So direct of 2, 3 is already 1. So that will be already included in 2 hop of 2, 3 equal to 1. But if you wanted to go from Delhi to Chennai, already you know one hop of Ij equal to 1. One hop of 2, 4 is 1. You already know that because from the one hop matrix that is already included in 2 hop of Ij. Okay. If you can go from Delhi to Chennai by taking one hop, that is also included in 2 hop of Ij equal to 1. You will make 2 hop of Delhi and Chennai also will be 1. Okay, but Delhi to Hyderabad, that is new thing because you have included Delhi to Bangalore, one hop route also you have included. Like Chennai and Hyderabad, that will be in direct of Chennai. Direct of, what you will do? Direct of 4, 5 will be 1 in the direct matrix because Chennai is the starting station and the ending station is Hyderabad. So direct of 4, 5 is 1. Okay, that you already know. But this one, Delhi to one hop of Delhi to Chennai you can go. One hop of Delhi means 2 and Chennai is 4 equal to 1. So you can go from Delhi to Hyderabad by taking this route, no? Delhi to Bangalore, Bangalore to Chennai, and Chennai to Hyderabad. So how many switches? One hop of ij will include one switch, and direct is nothing but you can go directly. So that is how you compute the two hop. So two hop is nothing but starting stations A and B such that you can reach B from A by changing at most two train. That means you can go by taking a maximum of two hops, two switches you can take. So how you will get the two switches? Like one hop is this one, direct. This is direct. So if you know, if you can go from a station I to J by taking one hop and by this Chennai is intermediate station now. And from Chennai to Hyderabad directly, a direct, then two hop of IJ will be one. Is it clear or you have some doubt? Any part?
Ma'am, I have a doubt.
Yes,
Ma'am,
please.
is it possible to go from one station to another station up to at most two hops if one hop is 0? That means, am I able to make my point clear? Like if I want to go from maybe Bangalore to Patna, and if one hop value is coming to be 0, I looked at the matrix, and if one hop is like 0, the value for one hop is 0, then is it possible for me to go from Bangalore to Patna?
Okay, you want to go from Bangalore to Patna.
Yes, ma'am.
Okay, so
And yes, ma'am. We can consider up to at most two hop condition. And if one hop in this case is 0,
okay,
then can I
Bangalore
go?
to Patna, you
Then
want
we
to
would
go.
have direct train, right, ma'am? If one hop is 0.
Yeah. So is there is direct train from Bangalore to Patna? No, you are telling no direct, no one hop. Okay, no one hop also.
No, this can't be possible, right, ma'am? Like after checking, direct we are updating to one hop.
See, you want to go from Bangalore to Patna. So let us say you can go from Delhi to Patna. Okay. Can we go from Delhi to Bangalore? You can go from Delhi to Bangalore, no? You can go from Delhi to Bangalore. And that means Bangalore to Delhi also you can go.
It will never happen because one hop matrix contains the direct matrix. So it will never be that one hop will be 0 and direct will be 1.
Yes, ma'am. That's what I
Yes,
was
that
telling.
is true.
Because one hop contains all the direct trains.
Yeah,
After
but
that,
what
one hop is updated.
there is no direct and no one hop.
Then
That's what,
there
no?
is no train, we can tell, no, ma'am.
Yeah, there is no train directly. You are telling no train directly from Delhi, Bangalore to Patna. You are telling no?
Ma'am, yes, ma'am. Like when I checked for the one hop matrix, I found that it is containing 0 value for Bangalore to Patna. Means
Yeah, okay.
there's no
That
like
means
one
no
hop
direct.
matrix.
That means no direct and no one hop also. No direct and no one hop also. Right?
Yes, ma'am.
Yeah, no
Then
one.
the procedure won't work out.
Okay,
Yeah,
so that means, ma'am, like I don't know if for one hop matrix we are considering the utmost case only. So
yeah.
whenever we are saying one hop,
See,
it
there
means we
can
are
be some intermediate station. No, there can be some intermediate station where we can go to some intermediate station like Bangalore to Delhi. We can go by using one hop, let us say, and by using direct, you can go from Delhi to Patna. You can go that way. So you are telling no one hop from Bangalore to Patna directly, but you can go from Bangalore to Patna by taking two hops. That can be possible. That can be possible.
that's my question, ma'am. Like
Yeah,
can I take yes, ma'am.
if there is some intermediate station between Delhi, Bangalore and Patna, if there is some intermediate station, by taking two hops, if you can go, that is possible. Some intermediate station has to be there.
And
Okay, so
then
that
also
means, ma'am,
this will be getting
it is
updated.
possible. That means, ma'am, even though our one hop is 0, but still
Even if
we
hop
can
is
go
zero,
with.
direct two hop can be one.
Okay, so two
Uh,
hop, the value for two hop can be 1. It is a
Yes.
possibility for
Yes.
this.
Ma'am, I disagree because when we are updating to hop, could you go to the pseudocode once, ma'am?
Yeah, but one hop, see,
We are checking one hop and direct.
yes, one hop
Yes.
of some intermediate K we are checking. So
Yes,
if you
ma'am.
are telling Bangalore to Patna, there is no direct, there is no one hop, there is no one hop. But what I am doing, can I go to Bangalore? Okay, can I go to Bangalore? Okay, I'm starting from Bangalore, and can I go to some intermediate station? And from that intermediate station, can I go to Patna? So let us say from Bangalore to Delhi, we can go through one hop, and from Delhi to Patna, we can go directly. Then we can take this shift, no? Two hops we can do, and we can go to Bangalore to Patna. So you can see here, Bangalore to some Chennai, let us say Chennai. Okay, now you can see this one, Bangalore to Delhi is one hop and Delhi to Patna is direct. Here we are not checking Bangalore to Patna one hop, no, we are checking Bangalore to Delhi and Delhi to Patna. So the K is different here. K is I and J are same. I and J are same. Like I is Bangalore and J is Patna. But K is what? K is Delhi here. K is Delhi. She's asking whether no one hop between Bangalore and Patna, but one hop is between Bangalore and Delhi to Patna, there is direct. Okay.
Hop we can consider only if we shift the train, right? Switching between the trains. Otherwise, if it is direct.
Sorry, could you please repeat?
Hop we can consider when we are changing the train in that
Yes,
station.
yes. Yeah, when-
Otherwise, it is considered as direct.
Direct, yes. Okay. If there is no one hop, but you can go that using two hop. That is possible. So Delhi to Hyderabad case also no direct, no one hop is possible. But by taking two hops, you can go.
Okay,
Delhi-
I understood, ma'am. Yes, I get it. Okay.
Ma'am, this is hectic, so I will take direct flight to Delhi to Chennai, madam. Time also less and cost also less.
Yeah, that's up to us, right?
Yes, ma'am. Simply said, yes.
So n-hop route. N-hop means at most n-hops you should be able to do. So what you will do, n-hop equal to one more hop equal to n-hop, you will check. You will say that is n-hop route. You are saying that is like you are naming it as one more hop. So you will make it as for one more hop, you are going it as n hops of ij equal to one more hop. That means for one hop, what you are saying, direct of ij, no, one hop of ij equal to direct of ij you are doing. So one more hop is n hops, n hops. So you are setting it to n hops of ij. So yeah, let n hops record the connections from station A to station B by changing at most n hops. At most n hops you can do. Okay. So in the case of one hop, what you have told, you can go from station I to station J by taking at most one hop. At most one hop. Here you are telling by taking at most n hops, like one hop or more than that, n hops. So you have n hops. Okay. You are just taking that, assigning that to one more hop, and you are checking n hop of ij equal to 1 and n hop some intermediate k, n hop of ik and direct of kj equal to 1, then one more hop of ij equal to 1. The same, if you have understood two hop, here how you are doing, you are just finding one hop of ik, some intermediate station between one hop and direct, the same thing. Here n hop, if you have some intermediate station, and directly you can go from that intermediate station to that j value. Then one more hop of ij equal to 1. So we can extend that, right? For three hop, what you can do? You can check whether you can go from station I to station K by taking two hops, and from
And then
station K
direct.
to station J, if you can go by taking directly, then that means three hop of ij equal to 1 you will do. That's what. Same thing here. Just if you understood the logic of one hop, two hop, then you can extend it. Okay.
Ma'am, like if I am trying to find out the case for maybe four hops, so I'll have to first calculate the matrix for one hop, like first the direct matrix, then one hop matrix, then two hop
Yes.
matrix, then
Yeah,
three hop
three.
matrix, and then
And-
for that four hop matrix, I'll pass the direct matrix and the
And
three hop matrix.
Yes, yeah.
Okay, so ma'am, like this will be very confusing. Like I'll have to like first prepare all these matrices and then I'll be able to find. So isn't there any other way by which we can look for, or this is the only way? If I'm looking for utmost 4 hops then in this case.
That's how you have to do only.
So
See,
I have
that is, if you think in the way of matrices, it is bit difficult. But if you see in the real cases, in the real whatever how you do, just you will, if you wanted to go from a station to another station, you will see whether we can go directly, whether there is a direct train, or you will see some intermediate stations you have. Okay, you will just map that stations. There is nothing like the procedure won't be this much difficult, tedious also. But yeah, but in order to represent in the matrix way, it is this how only. It's how you have to do.
This concept, why it is introduced in city? So, will be there any further
Matrices
functions?
or matrices, if you just this is
Mhm.
the real thing you are doing. But yeah, once you found this one, once you found the matrix, then trace the tracking is very easy, right?
Okay, okay. So to play
Ma'am,
within the matrix,
Yeah, once
or
matrix calculation is difficult. Matrix,
uh,
if getting matrix is difficult, but once you get the matrix, then you can go like for n stations, you can see whether there is one hop possible, direct possible, or yeah. But if you do like if we do manually, then you have to every time you have to compute. But once you got matrix ready, then you can play, right? You can go, you can
yeah,
check
yeah.
I can go directly or not. That thing you can do. But if
In
you want,
Big Nine, Big Nine, they introduced matrix, and here they are playing with inside the matrix. What another possibility we can do? Yeah,
yes, yeah.
Big
ma'am,
Ten.
this
Then
one more
you
hop,
understood or what? Yeah, if you
ma'am,
understand, yeah, yes, please.
ma'am, in this one more hop, it
Uh,
will give the value 1 even if there is one possible combination from
yes,
one station to the other station.
yeah,
It's direct, one hop, two hop, three hop, all the cases it will give 1. Means there
At
should be
least
some
one.
possible combination, at least 1.
yes, yeah.
Mm-hmm.
Okay, ma'am, okay, ma'am.
So yeah, in order to understand this, if you understand the one hop and two hop concept clearly, then we can extend it to n hops or any number of hops.
The thing is like previous terms of
Repeat the
mathematics
concept, ma'am.
as matrix. Right now there is no matrix content have been removed from math one. So only directly they went for graph theory after this differentiation. So that is a problem. It is matrix a little bit getting confused
Yeah.
because more or less it's similar. Like CT and maths, if you compute it, will be more or less similar subject will come. But however, matrix has been removed previously, so that it is a problem.
See, in matrix here, what you wanted to do
Excuse me,
for
ma'am.
CT is just matrix has some index. We have some
Excuse me, ma'am.
columns. Rows will start from 0, 1, 2. Like if it is say 3 by 3 matrix, we'll have 3 rows and 3 columns. The index will start from 0, 1, 2. Like 0 row, first row, third row. 0th column, first, like that is said, like you have the index from 0 to n minus 1. Okay, if 0, 0 is 1, that means we have edge from,
Excuse me, ma'am.
yeah,
0
yes.
to 0.
But
Can you
what is
please,
this?
hello?
Yeah.
Please repeat the concept in and hop codes.
Yeah, can you have you understood the concept of direct one hop, two hops? Yeah, could you please tell, have you understood the concept of two hops, one hop?
Yes, ma'am.
Yeah, if you understand that thing, then this is very simple. Just extending that thing. What is two hop? Two hop is nothing but one hop plus direct. What is n hop? N hop you are telling us n plus one hop. Like you can go from one station to other station by taking at most n hops, right? At most n hops. I think that is n plus one hop. This is n plus one hop. One more hop, no? N plus one hop. That means n hop plus one hop. N hop plus direct. Okay, I will write it. Just simplification. Okay, what is direct? You can go directly from station I to station J by single train. Direct of IJ means direct train. Direct train. No changing. Okay, direct train. Okay, what is one hop? Some intermediate train. If you wanted to say direct, one hop of IJ equal to 1, that means you can go directly by using direct train, or you can go by taking some intermediate train. Direct of IK, and if you can go from K to J directly, that means one hop by, that means you can go from station I to station J by taking at most one hop, either directly or you can go by taking one hop. Okay, one station you can change, one train you can change. Direct of IK or and direct of KJ if it is there, or you can go directly. Two hop is nothing but two hop, like at most two trains you can change. Okay, that means
Excuse
one
me,
hop,
ma'am.
one hop
Hop
include
means
one train, one hop of IK. Sorry, could you please repeat? Direct of KJ. The same concept. N hop equal to n minus 1. N minus 1 hop of IJ, IK plus direct of KJ. And n plus 1th hop. N plus 1th hop equal to n hops. If you can go n plus 1th hop of IJ equal to 1. If you wanted to say, that means you can go from station I to station J by taking at most how many hops? N plus 1 hop. That means n hop. If you can go from station I to station K by taking n hops, and if you can go directly from station K to station J, then n plus 1 hop equal to 1. Okay. This one, only this one thing you have to understand. Is any step not clear for you here, whatever I have written?
No, ma'am.
Direct one hop, two hop, this one, n hop is this one, n minus 1 hop. Okay, the same thing. Whatever we do practically the same thing. If you can go direct of 5K means, can we go directly from station I to station K? Like let us say the example of Delhi to Chennai. How we can go Delhi to Chennai? By taking Bangalore. So Delhi to Bangalore, there is some direct train, and Bangalore to Chennai, there is some direct train. So if there is some, that means you can go Delhi to Chennai by taking at most one hop. You can go to Delhi to Bangalore, and then you can switch at Bangalore, go to Bangalore to Chennai. That means you are going to Delhi to Chennai. The same thing here. Two hops means if you wanted to go to Delhi to Hyderabad, let us say. So you will go to Delhi to Chennai by taking one hop, and Chennai to Hyderabad you can go directly. That's how. Okay. That is two hops. Okay. The same way you can extend. Is there anything not clear in the steps? You can please specify. So if you have understood the previous things, no, if you understand the previous things, then it will be very easy.
Uh,
Any other things?
yes, ma'am. I want to ask one thing. Uh, Ma'am,
Yeah.
suppose I want to go from starting to ending station with two hops only. Like not at most two hops. I want to pass through two stations in between. I want two stations between my final destination and my starting destination.
Okay.
So, like here in the code, we have written that we are iterating through for each I in rows, for each j in columns, and then we took extra column k. Now I want
Yeah.
to go from I to K, then K to L, and L to J. So that for that L, I'll have to iterate through, do I have to iterate again through the columns?
So you won't check that many things because already you have one hop in a matrix, right? One hop is already there. So you will just check one hop is already there for us. So, okay, the same case like Delhi, Bangalore to Patna, you are telling, no? Bangalore to Patna. So you are starting at Bangalore, If you can go from Bangalore to Delhi by taking one hop, and
Yes.
Delhi to Patna, you can go by direct train. So one hop will include that. So the
Ma'am,
value of I will be Bangalore. Let me say the value of Bangalore and the value of J is Patna. Okay. One hop you wanted to say two hop of IJ equal to 1, two hop of Bangalore Patna equal to 1, you have to say, right? You have to see. There is one hop of Bangalore and Delhi is already included, one hop. So you will say K is this intermediate station, K. One hop of Bangalore to Delhi is already 1 equal to 1, and direct of Delhi to Patna is already there. So you can say
Ma'am, can you go to this pseudocode?
If exactly two hop we want, we will not initialize that one hop, at most one hop matrix to that,
Yeah.
so that we will get only
Here.
exactly two hops.
Yeah, man, this is two hops, right? So like J I to K and K to J and I to J again. That one again. So from we are intermediate, we are checking, right?
yes, I'm writing clearly here. Let us see. You can see. So what is our I? What is our J? What is our I and what is our J?
I is the starting station.
J is the ending station. So you saying
Intermediate, we are checking it.
Bangalore, Patna. So Bangalore is starting. Bangalore is I. J is Patna. So you are checking some intermediate K. K is Delhi, let us say. You can
That
go.
is one hop.
Yeah, that is one hop. So you can go from Bangalore to Patna, one hop of Bangalore, Delhi equal to 1 you have.
Correct.
And direct of Delhi to Patna you have. Delhi to Patna equal to 1. Then what you are doing? Then two hop of Bangalore, Patna equal to 1. That's what we are writing there. Our K is Delhi, our I is Bangalore, and J is Patna. So you are taking whether I can go from Bangalore to Delhi by taking one hop. If I can go, yeah, then one hop of IK will be 1. And direct of KJ equal to 1. That Bangalore to Delhi to Patna, you can go directly. So you are checking whether I can go. Okay, you know Delhi to Patna, you can go directly. And Bangalore to Delhi, you can go by taking one hop. So you will first go to Delhi from Bangalore, and from Delhi to Patna, you will go directly. Okay, then what you are doing? Two hop of Bangalore, Patna equal to 1. That's what. Just we are checking for intermediate K. The K is nothing but here if you are checking for two hop, then you will check one hop and direct.
The K is right now two hop means two intermediate station, right?
Yes, two intermediate station. In the two intermediate station, there is something here. So there must be some common thing here. So Delhi, you should go to Delhi by taking one hop. I told you, one hop. So that means Chennai, let us say. Chennai, Bangalore, and Chennai, Delhi. Some common station. So you are switching here. After reaching
However, you're right in Bangalore to Delhi directly. Bangalore to Chennai is supposed to write, no?
No, that is already included no, in one hop. In one hop matrix, Bangalore, one hop of Bangalore, Delhi is 1. Because you can go from Bangalore to Delhi by taking one hop. So in the one hop matrix, 1 half of Bangalore Delhi
Okay,
equal to 1.
okay,
That's
okay. So that it is Bangalore to the Patna, it is 2 hubs are available. Yeah, is there.
okay.
Okay, ma'am. Thank you.
Yeah, in the yeah, just see, this is not that difficult. Whatever you with like not that much difficult. Okay, just understand it practically, then you will understand. Okay.
Yes, ma'am.
Yeah.
So
that-
this hop is a function, right?
Yeah, hop is a method, yes, function.
Okay, some other language it is useful for some checking in depth in between something.
So yeah, any other things you have? Anything in other weeks? In week 10 or week 11?
Next lecture is there, ma'am, but time is up.
Time is up. That's what I thought.
No problem. Monday we'll discuss.
Yeah,
Actually, week 10 is
Ma'am, you
confusing, ma'am.
have
No
class
one has
on Monday.
we have more sessions. It's okay.
But
Okay,
next
ma'am.
lecture, what is there after?
distance, it seems like distance between two stations.
It's between
Path.
No, next lecture you're saying after there is no lecture, right?
the 10.4 is it? Now we have discussed.
10.4.
Okay, got it.
That
Sorry.
is not short. That is not short. There is also procedure, right? That is not short. This will take one session, I think. Then.
Okay, ma'am. Okay.
Yeah, I cannot. Yeah, this is not short. This is lengthy only. Maybe probably in the next session you can see. Okay. Anything, whatever we have discussed, any doubts?
And the thing
No,
is
ma'am,
like
that much clear.
after 11th week summary, we are conducting 10th week summary, ma'am. This is the thing I want to tell you.
Yeah, I don't know why that has happened. Why it has happened? What happened in the yesterday session? You haven't asked about week 10 summary.
The thing is, she wanted to complete, and she's saying tomorrow there is a class. You can ask your doubts of week 10, whatever you can do.
He was not well actually yesterday.
That is also matter. However, yeah, she was not well, but still she explained very well of
Yeah,
week 11.
11th week she has done well.
But
Yes,
if
ma'am.
it is like same continuous, then it will be very harder to understood. But however, that is totally different. That recurring process or something.
Yes, ma'am. Yeah, no problem. Yeah,
No
everything
problem.
is
Yeah.
nice.
Yeah. Okay.
Thank you.
Your
Thank you for
doubts,
your patience.
If you have any doubts, no, in any session, if you have any doubts, please mention. That means if she is not able to take in the like this in
Excuse
the
me,
current
ma'am.
session, then we can then in the next session she will take. Okay. Like if I
Yeah.
okay, if I am taking this session, okay, today's session, you ask me 10 okay, I not
Excuse me, ma'am.
week 11. Okay, but I haven't prepared for week 10. But you asked week 10, so I took week 10. But in the some cases yesterday she is not when you are telling me. Yeah, she might not have prepared for week 10. So she told like, yeah.
No, I'm not complaining or
session.
something, but however that the sequence was not happened because
I
by
understood.
the rush we are rushing the subject.
See, if you have any doubt in any session, if they are not, if they are, you should mention in the current session. If they are not getting cleared, then in the next session we can take. Okay, so that means in the next today it has not happened. So in this session it has cleared. So I now 10.3 only finished. In the next session I will take whoever has taken the next session. I will tell to take the 10.4 slide. Okay.
Okay, ma'am.
Yeah.
Thank you.
Okay, just if you have something you mention, then only we will know.
Thank you, sir.
Then you have.
Excuse me,
Yes.
from 8 to 10, is there maths 1 class today? Like in calendar, it's not showing.
No, ma'am, no class.
Okay.
Tomorrow there might be a class. Yeah, there is a class.
Okay, I will tell like whoever is taking the next session, I will tell them to teach 10.4. Okay, that's code.
Now the
Okay.
next session with the Monday, solve with us city 6 to 8.
Okay, next session you want 10.4 and week 11 something activity questions or everything or what?
10.4 is main
Yeah,
focus, ma'am.
please
If time is
complete
left
this.
over,
After
we'll
that,
do something.
go ahead, ma'am.
Yeah, sure. Sure. Yeah, I will tell the same thing. 10.4 is still pending, and if 10.4 is discussed, then go to week 11 activity questions. Week 11 practice questions are already done, no?
Yes, ma'am.
Yeah, sure. Okay, thanks all.
Thank you, ma'am. Thank you so much.
Thank
Thank
you
you,
for
ma'am.
your patience.
Thank you so much.
Thank you
you,
so
ma'am.
much.
Good night, ma'am.
Thank you.
Thank you, madam.